Let's solve a derivative problem step by step. We're given the function y equals ax times 1 minus x, which can be rewritten as ax minus ax squared. We need to find the value of a such that the slope of the tangent at the origin is equal to tangent of 60 degrees. Let's visualize what we're looking for. Here's our coordinate system. And here's what our function might look like for some value of a. We need to find the value of a that makes the slope at the origin equal to tangent of 60 degrees, which is equal to the square root of 3. Let's solve this step by step. First, to find the slope at any point, we need to take the derivative of the function. Using the power rule and the constant rule, the derivative dy dx equals a times 1 minus 2x. Now, we want the slope at the origin, which means we need to evaluate this derivative at x equals 0. When we plug in x equals 0, we get that the slope at the origin equals we're told that this slope should equal tangent of 60 degrees, which is the square root of 3. So we can write the equation, a equals square root of 3. Therefore, the value of a that makes the slope at the origin equal to tangent of 60 degrees is the square root of 3. Let's verify this visually. Here's what our function looks like when it equals square root of 3. Notice how the slope at the origin is exactly tangent of 60 degrees. And that completes our solution. We found that it equals square root of 3 by taking the derivative, evaluating it at the origin, and setting it equal to tangent of 60 degrees.